んにちは、皆さん。Ms.P です。Hello everyone, I'm Ms.P. How are you everyone? I hope all of you are safe and well. So today, I'm gonna teach you Year 2020 MIT Integration B Test Program Level 5. Okay, so actually this is repeated definite integration. Okay, so here's the problem. Integral from 0 to pi over 2 of sine squared of sine of x plus cosine squared of cosine of x dx. So first of all, we're going to change this expression by following trigonometric identities. Okay, so let's do. So is equal to integral from 0 to pi over 2 of parentheses. So I'm going to change sine squared of sine of x into 1 minus cosine squared of sine of x. Okay? Since sine squared of sine of x plus cosine squared of cosine of x is equal to 1, right? So, next one, plus, I want to change cosine squared of cosine of x into 1 minus sine squared of cosine of x dx. Okay? So, this is the point. Okay? So, next, I'm going to organize. We have to organize this expression. However, I want to make two separate integration. Okay? So, let's do. Is equal to integral from 0 to pi over 2 of, so 1 plus 1, which is 2 times dx. And next one, negative cosine squared of sine of x and minus sine squared of cosine of x. We're going to make this together, and I'm going to bring minus in front of integral. Minus integral from 0 to pi over 2 of parentheses. So I'm going to bring sine squared first. Sine squared of cosine of x plus cosine squared of sine of x and dx. Okay? So, this is the point. And next, we're going to use substitution. Okay? So, I'm going to show you here. Let x is equal to pi over 2 minus u. Okay? This is the point. Okay? So, now we're going to make the u is equal to pi over 2 minus x to find the bounds later with respect to u. Okay? So, next step, we're going to differentiate this equation. So, that is dx is equal to minus du. Okay? And the next one, you know what? This is repeated definite integration. So, I'm going to put this one is equal to I. Okay? This is I. So, we want this integration the same as this one. So, we wanna cosine here for sine, cosine to sine. We wanna sine here we wanna cosine here. Change sign to cosine, okay? So how we're gonna do? We're gonna do this way. So first of all, cosine of x is equal to cosine. X is pi over 2 minus u, so cosine of pi over 2 minus u. Okay? And then cosine of pi over 2 minus u is equal to sine of u. Right? And next one, sine x. So we're going to change sine x. Sine x is equal to sine of, same thing as here, pi over 2 minus u. And sine of pi over 2 minus u is equal to cosine of u. Okay? So now we can change everything in this integration. Okay? However, this is going to be the same. So I'm going to rewrite over here is equal to integral from 0 to pi over 2 of 2 times dx and minus integral. Okay, so bounds going to be different with respect to u. So lower limit 0, pi over 2 minus 0, which is pi over 2. Lower limit u is pi over 2. How about upper limit? Pi over 2 minus pi over 2, that is 0. That is 0, okay? And then, parentheses, sine squared of cosine x. Cosine of x is sine of u. So, sine of u plus cosine squared of, okay, sine of x is cosine of u, right? Cosine of u. And then dx is negative du. So I'm going to put the negative du here. And now we can take advantage of this negative 1, this negative sign, to swap the bounds, okay? So this is going to be plus, and then switch the bounds. So integral from 0 to pi over 2 now. And then I'm going to rewrite this one, plus du. I'm just going to write it just du, okay? Just du. Just du. And then you see, this and this are just different about variables. This is x variables, and this is u variable. However, the calculation is the same, and then the value of both integration are the same. So we can say this is equal to I. Okay? This is I. This one is I. So minus I. So we want to bring this to the left side. So negative will be positive. So I plus I, that is 2I. Right? And then the left over here is equal to integral from 0 to pi over 2 of 2 times dx. This is it. This is the process, okay? And then now, we don't want a 2 here. We don't want a 2 here. We want to divide both sides by 2. So that is cancelled out, 2 and 2. And actually this is 1, right? Because we want to figure out the value of I, okay? And then this is 1 dx, so integral of 1 is 1. So that is x that is x, and bounds are from 0 to pi over 2. So what is I? So we're going to plug pi over 2 and 0 into x. Actually, that is pi over 2 minus 0. So I is equal to, final answer is pi over 2. Right? So this is the answer, pi over 2. So, how was today's lesson? I hope today's lesson was very helpful. So, see you next Monday. Next Monday, okay? So, have a nice week. And also, have a nice summer. Bye! Hi, Nora. You really love me, huh, honey? You really love me. You're always here, You really love me. Honey, I love you. I love you, Nora.